Hi, welcome back to my lab. Today this will be the last episode concerning this laser rangefinder here. Today I will try to activate the laser itself. So as you can see, I have received the safety glasses. So the safety glasses is the model DTY52 from Apinex in Montreal. The cost of the safety glasses is 67 euros. You can find safety glasses at different prices, from 10 euros to 300 euros, depending if you have a certificate or not and stuff like that. So I have found this intermediate price, so I hope that these glasses are safe. So let's start the test. First of all, I have already performed some tests on that device. So I have applied a voltage of 28 volts to that board here. So this permits the control of the lamp and the Q switch. The input is here. I have applied a pulse of 10 volts approximately, and the duration of 1 millisecond or so. I have checked that there is effectively a pulse. The duration of the pulse is around 100 microseconds in order to activate this SCR. So this permits to connect the discharge lamp to the capacitor, which should be previously charged. There is also at the same time a pulse. The duration of the pulse is also 100 microseconds. The duration of the pulse is defined by this RC network here. The third thing is the activation of the Q switch. So the input is here. There is a delay of 120 microseconds, which uses this 121 monostable. It is possible to adjust the duration of the pulse using this trim pot here. This time permits to pump the ND-YAG crystal rod. On the falling edge of the output pulse, there is a saturation of this transistor, so this permits the activation of the Q switch. The signals are here. This is the input pulse, this signal here. This is the output of the monostable, pin 6 here. The duration is 120 microseconds. And this is the signal at the input of the transformer for the Q switch. So the duration of the pulse is around 100 microseconds also. At this time, the feedback of the laser is activated, so the laser beam is generated. This time is important, it permits to have the optimum pumping of the ND-YAG crystal rod. This is the second step. I have connected the primary of the transformer to a power supply of 115 volts, 400 Hz. There is a switch in series, this one. I have connected also this point to the high voltage probe. It is this point here. The high voltage probe is here. The high voltage probe is connected to the oscilloscope. I have connected also the input to a function generator. This input here. The function generator is here. It is a HMF 2550. It is possible to generate a pulse when pressing this push button. For the moment, only one pulse is programmed, but it is possible to program any number of pulses. We will see later if we can generate a burst. For the moment, the charging capacitor cannot be charged. Okay, so let's turn on the power supply. I have configured the oscilloscope with a probe of 1000. I think the ratio is 1000. So the voltage is exactly 1 kilovolt. The power supply is 113 volts. The last step will be to add the circuit which was removed by Ferranti in order to charge the capacitor. Okay, so I have connected everything. First, I will turn on the 28 volts power supply. Okay, and now I turn on the 115 volts. Okay, so let's go. I will activate the manual trigger of the function generator. 3, 2, 1, 0. Okay, so you can hear the noise. And you can see also the flash. It is of course impossible to see the laser beam, but it can be possible to see the effect of the laser beam. So I have placed, as you can see here, a small anodized aluminum plate here. The black paint permits to dissipate the energy of the laser beam. Okay, so let's have a look. That's all for this laser rangefinder. Thanks for watching and see you next time. Bye bye.